Today I would like to share some knowledge about how to port Android applications and Windows Store apps. If you have experience in developing Android applications, this course is for you. Because of time limitations, I will not touch on the details. Instead, I will try to create mapping for relations between Androids and Windows Store apps on an advanced level. After this course, I expect that you will know the difference between the two platforms and the best replacement when your port is certain feature to Windows Store apps. This session will be broken into 5 parts: programming architecture, UI controls, application life cycles, notification mechanisms, and lastly, data storage. Now let's first have a look at programming architectures. As you may know, Android is a Linux-based system which is totally different than Windows NT kernel. As an Android developer, you probably don't understand the programming architecture of Windows Store apps at first sight. I will compare the programming stack layers between them so that you have a clearer picture. This graph is programming stacked for Android. As you can see at the bottom, there is a Linux kernel, which provides the driver level of support for devices. The upper layer is libraries and Android runtime. These libraries are native code, which cannot be used directly by Java applications. However, they provide reusable system-level functionalities. Android runtime includes Dalvik virtual machines and code libraries. Dalvik virtual machine is used to execute Java code. These code libraries provide Java language-specific functionality. The application framework provides the APIs used by Java applications. Next, let's have a look at programming stack for Windows Store apps. Similarly, the bottom layer is the Windows core, which also provides the driver level support. The green layer is the WinRT library. Windows Runtime Library is a native library, but it can also expose APIs directly to different languages by projection. WinRT APIs are the successor of the old Win32 APIs in Win8. We can divide the WinRT APIs into multiple namespaces, for example, UI, storage, network, media, and so on. Windows metadata describes the type of window runtime objects. Language projections here is a way to expose native APIs to 3 types of languages: native language such as C and C++, managed language like C# and Visual Basic.NET, and web language like JavaScript with HTML5. Besides WinRT APIs, Windows Store apps also support a subset of Win32 APIs. If the application is written by managed code, like C# and VB.NET, a subset of .NET APIs is also supported. You can check which APIs are supported by Windows Store apps from MSDN. According to the program stack, we can get a component map table between Android and Windows Store apps. Android is built on Linux kernel, while Windows 8 is built on Windows NT kernel. It is different, but these are totally transparent to the developer. Android integrates Dalvik virtual machine to execute Java bytecode. The corresponding virtual machine for managed language is Common Language Runtime. Actually, it's a just-in-time compilation engine. Unlike Dalvik virtual machine, the managed code should be compiled into intermediate language IL at the compilation phase. Then, CLR engine compiles the IL code into machine code at runtime. This mechanism can render better performance than Java Virtual Machine. Android libraries are native libraries, which provide reusable system-level functionalities and resources. In Windows 8 platform, Windows Runtime Library plays the same role, which is native and reusable. If you want to develop games, DirectX Engine is the replacement of OpenGL-ES libraries. Android provides a framework to expose required APIs for Java applications, while for Windows Store apps, APIs are exposed by Windows Runtime libraries. We just use WinRT projections to bind them into different languages. If you are writing a code in managed languages such as C# and VB.NET, you can also use the subset of .NET libraries for Windows Store apps. Both of the two platforms support different programming languages. We write Java code in Android. If performance is critical to application, we can also write Android components in C or C++. while in Windows 8 platform. We support multiple languages. We can write both business logic in UI in C#, VB, and C++ or JavaScript with HTML5. C#, VB.NET, and C++ can also be used to develop WinRT components. So in theory, you can choose any of them to develop the applications. But most equivalent languages for Java is C#. I strongly recommend that you write in C# code when you port your Java application to Windows Store apps. C# language syntax is similar to Java, which makes it easier to convert Java code to C# code. We can write both UI and business logic in C++ in Windows 8 platform. But in practice, we just use it to write customs WinRT components instead of applications. To write customs WinRT components easily, we need to use C++ extension called CX. The CX extension introduces some new concepts, such as delegation, events, and hat reference. Most of these concepts are similar to those in C#, but standard C++ code is still supported. Just a reminder that you should expose the CX type instead of standard C++ type so that the upper layer application can recognize it if you want to wrap the C++ code to a custom WinRT library. So in short, if you are using Java language to develop Android apps, you convert the C# to write Windows Store apps. If you are using C or C++ to develop Android libraries, you can also use C++ to develop WinRT components. Both Android and Windows 8 provide a complete set of tools to develop applications. Here I list tools required in these two platforms. To develop Android apps in Windows platform, you should install Android SDK and related SDK tools for Windows. To develop Windows Store apps, Windows 8 SDK is required. IDE is also necessary to edit and compile the code. You can choose Eclipse with ADT plugin to develop Android apps. For Windows Store apps, Visual Studio 2012 is the only choice. Visual Studio 2012 is a powerful development tool which has included the necessary components of Windows 8 SDK. Therefore, you don't need to install Windows 8 SDK separately if Visual Studio 2012 is installed. To design Android app UI, you should install the ADT UI plugin in Eclipse. DroidDraw is another choice. However, Visual Studio 2012 has embedded the UI design tool. If that's not enough, Microsoft also provides a more powerful design tool, Expression Blend, which currently included in the Visual Studio 2012 installation package. Just similar to the embedded debugger in Eclipse, Visual Studio 2012 also provides a powerful debugger tool called VS Debugger. It helps the developer to trace the code, set breakpoints, and view various data in the memory. WinDBG is another debugger tool, which can also debug applications on system-wide level. Android provides an emulator Android virtual device, which helps test applications without the real Android device. Because Windows Store app runs on Windows 8 platform, emulator is not required, but for the sake of testing applications on tablets, we still provide a simulator for tablets. It can help the developer test the layout with common touch and rotate events. After the overview of programming architecture, let's have a look at controls that we use in Windows Store apps. Android provides plenty of widgets. In the Windows Store apps world, it is called widget control. Similar to Android, we use two types of controls, layout control and content control. We call this the layout control panel. There are various panel controls in Windows 8, such as canvas, stack panels, and grids. Besides, we also provide a lot of content controls with Microsoft Design Style UI. More importantly, you can customize UI to what you want without rewriting the controls code. So, it is much more convenient to beautify your UI. Accordingly, some of the widgets in Android can map similarly with Windows Store apps controls. For example, panel is similar to view group. It's an abstract object of layout controls. Canvas is like absolute layout. It is used to place the controls with absolute coordinates. Stack panel is like linear layout. It can place the controls one by one. Grid panel is comparable to grid view. It divides the client area into rows and columns. App bar is equivalent to option menus. It shows commands for applications. Text box or text block can be used to replace edit text. It depends on whether the text can be edited. If you need to input some words, you should use text box. If you just want to display some labels, you can use text block. Although text block also works, text block is much more lightweight than text box. And toggle switches is like toggle button. It is used to toggle between two states. Again, image control is similar to image view. It can be used to show bitmap, PNG or JPEG format files, or streams. Media element is equivalent to media controller. It controls the playback of video and audio. Slider is like sleek bar, which allows users to select from a range of values. Flip view is a substitute for view flipper. It's used to display and flip items one by one. Web browser is like web view. It's a web host for HTML content. Map control is comparable to map view. The difference is that map control uses Bing Map instead of Google Map. We have just mentioned the controls which have a lot of the same or similar functionality but with different names. Still, there are some controls with the same names and same functionalities, such as button, checkbox, and list view. If that's not enough, there are also a lot of third-party controls provided on the internet, or you can write custom controls by yourself. Unlike Android widgets, Windows Store app controls can also be divided into two categories: user controls and custom control. The user control is a traditional concept. It just assembles the existing control. It cannot separate UI and logic. So in most cases, it is used within a single application. However, the custom control is totally different. It's a look-less control, which means its functionality doesn't depend on its view. It can only apply any view you want to control. But in practice, we only provide a default view. We call it the generic theme. All the built-in controls are customized control. In theory, we can customize the built-in control to any desired view. But please don't abuse this feature so to keep the UI style elegant and unified. As you know, in the Android world, we use XML to describe the UI. In the Windows Store app world, we use XAML to describe the UI. XAML is an XML-based markup language. Therefore, it has similar concept and syntax as XML. The XAML namespace decoration is almost the same as XML namespace in Android. It just uses the different namespaces and prefixes. You can also treat XAML structure as element attribute tree. Each control is XAML element and each property is XAML attribute. XAML can also define resources and styles, which can be referenced in the same scope. XML language, however, is more flexible than XML in Android. For example, control containment property in XAML can accept any type of objects. So, you can show text, image, or even video on one button control without writing the new type of button. That's what we call containment friendly. Another key difference between XML and XAML is that XAML owns the template. The template can be used to replace the view completely. We can define the template with the different view, and then use this template to replace the control's default view. The lifecycle of Windows Store apps is significantly different from that of Android applications. To reduce the power consumption of the system, the Windows Store app is well designed so that only visible applications can consume the CPU time. The applications which are invisible fall into a suspended state, and they can be terminated without any notification when the system wants to recycle the resources. On the contrary, Android always keeps invisible applications running unless the system's resources are not enough. This is a graph comparison on multitasking between Android and Windows Store apps. Android application keeps the process as long as possible, so it can perform multiple tasks by worker threads and services without any additional code. Windows Store apps, however, will suspend any invisible processes. The suspended processes still stay in the memory, but they cannot get CPU time unless it gets resumed. It means by default, any task will be stopped if the application is switched out. It's fine for most scenarios, but can cause severe issues when the applications require back-end network connections to download something. To solve such kind of issues, we define scenario-based multitasking activities and make a series of interfaces to deal with these scenarios. Background transfers can help download or upload files in the background. Background tasks can help run the code in the background without launching the application. In addition, the media element control also integrates the capacity to play audio in the background. As you may know, Android application lifecycle is activity-based. In Windows Store apps, a page is similar to an activity in Android, so we can compare the lifecycle methods between them. When you launch an application in Android, you can use the onCreate method to initialize the components. The application then receives start and resume events, which allows you to load settings and private data. The previous application receives pause and stop events accordingly, which allows you to store settings and private data. In Windows 8, you can call initializeComponent method in the constructor of the page class after the application receives onLaunch event. The application also receives resuming events when it is activated and gets suspended event when it is switched out. You can also do similar work to save application data in these two event handlers. You can switch the pages or activities inside process. In Android, when one activity replaces another, the current activity invokes the onPause and onStop callbacks, and the new activity invokes the onResume callback. This behavior is similar to the page-to-page navigation in Windows Store apps. In Windows Store apps, while moving from one page to another, the current page invokes the onNavigated-from callback, and the new page invokes the onNavigated-to callback. Both Android and Windows 8 have notification services. Notifications play a key role in Windows 8. Windows 8 provides a number of different means to show notifications to users. You can show a message using a dialog, prompted a toast for a time-sensitive notification, or update the status in LibTab. Here I'm going to compare the notification mechanisms between these two platforms. This is a notification mapping between Android and Windows 8. The dialog notification is a modal alert that the users must respond to. In Windows Store apps, you can use the message dialog to do the same thing. In Android, status bar notification is persistent information that requires the user to respond. In Windows Store apps, the tile notification is the replacement to show such kind of information. You can show the text, image in the tile, and there is a badge in the tile which can show the number or status. Toast notifications is the time-sensitive non-persistent message. In Windows 8, toast notifications are shown for about 7 seconds for a standard toast, or 25 seconds for a long-duration toast, and the user may choose to ignore them. This behavior is similar to Android toast notifications. Windows Store application notification is more powerful and flexible than Android notification. There are 4 mechanisms that an application can use to deliver a notification: local, scheduled, periodic, and push. And the notification position can be tile, badge, or toast. The local notification can be used with tile, badge, and toast while the application is running. The scheduled notification can be used with the tile and toast to update the information at the specific time. The periodic notification can be used to update tiles, badges regularly at fixed time intervals. The push notification can be used with tile, badge, and toast to get notifications from one cloud server, even if the application isn't running. Both Android and Windows 8 provide 3 different ways for applications to store data locally: application settings, files and folders, as well as databases. The difference is that Android applications can access not only internal storage but also external storage. Just the same as Android, the internal storage area is private to each application. But for Windows Store app, Only the specific external folder can be accessed, such as documents, pictures, and music folders. If you want to access an arbitrary file in the system, you should use the file picker to select the file. Another thing to take note of is that Microsoft doesn't provide database support for Windows Store apps. Thanks to SQLite team, who developed an extension to support Windows Store apps, we can now write the Windows Store apps with local database support by using this extension. Now let's have a look at how to store application settings. In Android, shared preference class is used to access settings data. In Windows Store apps, the replacement is application data container. To get the container object, you can call get shared preference or get preference in Android. In Windows Store apps, you can get it through local settings property. The application settings can also roam to other devices. In this case, you can use roaming settings property. Generally, you should load settings when the application is activated and store settings when the application is closed. In Android, we just fetch the data in onCreate functions and write data in onStop functions, while Windows Store apps fetch settings in onLaunch and onResuming functions and writes data in onSuspending functions. Besides application settings, Windows 8 also allocates isolated storage for every application to save private data. There are 4 different folders. Local folder is used to save persisting data that exists only on current devices. The data in the temporary folder works like a cache. It can also be removed by the system at any time. The data in the roaming folder exists on all devices on which the user has installed the application. The application can also access the installed location folder, which contains the application package. This folder is ready only, so you can't write data to this folder. Windows Store app doesn't provide general external storage due to security reasons. You can access some known libraries such as documents, videos, music, and picture folders, but you should declare the capabilities in manifested files before accessing them. You can also access SD storage through Removable Devices property. For security reasons, Windows Store application won't allow access to arbitrary files in a device implicitly. If you want to access a specific file, you should use File Picker to select this file explicitly. Then the application gives permission to access it. In this session, we've compared the Android and Windows Store apps development in terms of programming architecture, UI controls, application life cycles, notifications, and data storage. You can see that it's not trivial to port an Android application to Windows Store app, but you can still leverage your existing code and skill sets in Windows Store app development. Thanks for your time with us!